For the first enhancement, we're starting with a featureless body that we bring into the flexible printed circuit design application, and we plan to do a convert. We run the convert command and it defaults to uniform thickness. We select the base face and then preview, and we can see a number of alerts have come up. It's telling us that the body has non-uniform material thickness, so that leads us to believe it's a multi-thickness part. So we change the type, reselect a base face that's appropriate, and we have another look at the message alerts. And what we can see here, we've got three alerts. The first one is telling us that we've got some issues with the part, but these issues to do with non-tangent bend faces can be adjusted for us. There's nothing for the user to do. The second one is talking about highlighted faces are fused together. Now this is something the user will need to fix before we can continue. So the message there is saying to try and make changes to the geometry to remove this situation. The third issue, highlighted faces are bends with non-concentric faces. These are radii that are not concentric, and they're also adjusted for the user. So let's now go and fix the problems, and there's a number of ways we can do this. We can modify the geometry within the application, but for this example we're going to switch back to modeling and use synchronous tools just to delete that problematic face. So we just delete that, and what we'll do, we'll fix this up later when we come back into the application. We switch back to flexible printed circuit design, FPCD, and we rerun the convert command. We know it's multi-thickness, so we make that selection. We select our base face and preview once more, and we can see that we've just got things that are going to be fixed for us. And also a warning message at the bottom there telling us that a layer scheme is going to be created. Once that's been done, let's go and have a look at the layer scheme. And we can see here in the multi-thickness segment, layer scheme 1 has been created, and if we go and edit that, we can see a number of different zones with thickness and offset have been created for us. So the part is complete and finished for conversion. What we need to do now is to go back and fix up that bend that we removed. But before we do that, let's just have a quick look at the success of the conversion to make sure we can create the flat form for the entire design. And using unbend just shows that this is possible. So when I go and fix up that radius or the bend relief that has been removed, and we'll use the break corner. And using this command, it will control what is permissible in terms of the size of the radius that we can put in there. And there we have our design converted and ready for the next step in the process. Moving on to the next enhancement, this is about associating assembly components to a flexi circuit design. So if we go to the PCB Exchange application, we can see we've got no component attributes defined here, so it is purely just a simple NX assembly at the moment. We look at the assembly navigator and the constraints navigator, and we can see that there's just assembly components and no constraints. So we run the associate object command by selecting individual faces, and the enhancement here is that it accepts the assembly components by changing the selection scope from within work part to entire assembly, and you can also see the interpart link has been enabled. So we select the face, we select the components, and we'll do this for each area of the circuit board. And what you can see in the part navigator is linked bodies are being created to keep all of the associativity. Now that's complete, we can go on to the next phase of the design, which is creating the flat solid features to show the design in different flattened or semi-bent states. So we'll create the first one here. We'll offset it a distance so we can see clearly between the formed and the flat states. and we'll just OK that, and the flat form has been created as a flat solid. If we go back and edit that now, and we go into the settings, we can transform the components as bodies. So based on that association that was made with the associate object, we can see all of the assembly components are now have instances or copies on the flat solid feature. We'll go back into flat solid and create another one just to show that we can have multiple flat solid features here. Again, we'll transform the bodies, and here we'll just put this one on a different layer and we'll make it a different color just so there's clarity. So we can see we can have different states of flat and semi-bent of the circuit board. We'll just rebend the middle one to show that we'll have 3 different states of the design. We'll just rebend one of the bends there, so we can clearly see different stages within the circuit design. Now if we switch to drafting application, we can push these different views down into the drawing, and here we've got a number of views set up with certain layers visible in view. So we've got clarity between the 3D form, the in-process state and the fully flat state shown on the drawing. So moving on to the next enhancement here, this is in the visual reporting tool, and what we can do here is get visibility of a flex circuit in terms of its different sides, its top face and its bottom face, or its A side and its B side. And this is valuable when you have a complex circuit which folds this way and that way, and you can clearly see which components are on the top side and which components are on the bottom side in both the formed and the flat states. A nice little design analysis tool. Switching across to PCB Exchange, we can see the next enhancement here is the way that we assign attributes to components. There's no longer a need to select the actual component, but before we do components, we'll just assign the PCB Exchange attribute to the board. So we'll pick the board as an object here, and what it's doing here, because it's a multi-thickness or a rigid flex design, it will create a different zone or a different area for each thickness within the design. And you can see that in the navigator. When we move on to the components, I can select the instance on the flat version and it highlights the assembly component on the form version. So we've got full flexibility of where to select and assign those attributes. We'll do one more, and you can see those part number and reference designators are entered, and they appear in the design navigator on the left there. If you select from the navigator, all instances of that component are actually highlighted for clarity. Moving on to the next enhancement, this is about visualizing the pin 1 of the components and the center control point in all views in the design. So we can see here, if we go across to PCB Exchange, we can see the MCAD primary pins shown as the black pins. In the form state here, we've got all of our attributes assigned, and when we go back across to create the flat solid in the FPCD application, we'll be able to see those transposed. But let's have a look to see how that actually happens. If we look at one of the components, there's 2 things that need to happen. First of all, for pin 1 identification, we need to have a datum point with a specific attribute name, and we need to have a point with a specific name called CCP. Once those 2 things have been defined, these things can be transferred across onto the flat solid representation. And this is useful for marking up and dimensioning and so on in downstream process. So we'll create the flat solid feature. For now we will just specify the default layer, and we'll just move the components across. Nothing new here. If we go back in and edit that flat solid feature and turn on the pin 1 and CCP transformations, we can now see the datum points appear on the flat solid feature, and if we went back to PCB Exchange we could also see the MCAD primary pins being identified. And we switch across into drafting, and we can see in the flat state we can see those pin 1 and CCP datum points have been included, and this is useful for defining the position dimensionally with dimensions for each component.